limits tutorial. When we're trying to evaluate the limit of f of x as x approaches c, there's several steps that we need to do. The simplest step and the first step is to substitute the value c for x inside the function and calculate an answer. If we get a finite number, something that's not undefined, then that is the answer for our problem. If in the calculation we get 0 divided by 0, our problem is indeterminate, meaning we don't know if the limit is going to exist or not. We can use the replacement theorem to simplify f of x either by factoring or possibly rationalizing the radicals depending on the problem, and then evaluate the simplified or reduced function a second time plugging c in for x. If in this second time we get a finite number, that will be the answer to our problem. If we get a divide by 0, then the limit for this problem does not exist. In our first problem, we have here limit as x approaches -3 of this rational function. Our first step is to substitute in -3 and calculate. As you can see in this example, we got the indeterminate case. We need to go back now and try to simplify our rational function. The numerator can be factored as x minus 2, x plus 3. The denominator was already simplified. We have x plus 3's that we can cancel out. So our reduced function is just x minus 2. We now substitute -3 in for the x and calculate, and our answer is -5. In this next example, we have a radical in the expression, and when we substitute in, we get 0 over 0. Again, this one is indeterminate. In this case, since we have the radical in the numerator, we need to try to rationalize the numerator. To rationalize when we have an expression of a radical plus something or minus something, we multiply by something that looks like what we might call its conjugate. We change this minus to a plus. This pattern, when we multiply the top, we're going to get square root of x plus 4 squared minus 2 squared. On the bottom, we're just going to multiply and put the parentheses there. Don't bother doing the distribution. So after multiplying the top, we get this expression. On the top, we can combine the like terms and we simplify to x. We can cancel out an x on the top with the x on the bottom, giving a function of 1 over square root of x plus 4 plus 2. We now, in the simplified version, substitute for x equals 0 again and calculate. This time the limit does exist and it's equal to 1/4.